All right, you're an engineer. You're designing a can. There's a reason why all these cans look more or less the same. When you go to Walmart or the gas station or whatever, and you see a bottle that says uses 25% less plastic, and they're right, it's safer for the environment. But do you really think companies are motivated by making stuff safer for the environment? They're motivated by what? By money. And if they use less material, that is more profit. So all these designs that you see is because of this optimization, modeling. So here we're going to design. It says you have been asked to design a 1 liter oil can shaped like a right circular cylinder. The way, oil cans they don't look like right circular cylinders. But if we're going to make one that has the least dimensions, that uses the least material. What dimensions we use the least material? All right, before we start, guys, for those YouTubers wondering what that noise in the background, it's a printer. Because I'm recording, guys. All right, before we start, there's a few things that we must know. And this is something that makes the metric system super amazing. 1 liter is equivalent, do you guys know, to how many cubic centimeters? Okay, make sure you guys know this. 1 liter is equivalent to 1,000 cubic centimeters. So before you guys graduate...
Centimeters like space?
Yeah, but it's cubed, so that's volume now. All right, so here we go. Volume of this cylinder is pi r squared, which is the base, times the height. So there it is. There's my 3 dimensionals. And I'm going to equal that to 1,000. That's my restriction equation. And I want to use the least amount of surface area. So I'm going to call that area. And I'm going to write area is equal to, let's see, the circumference of a circle is, well, first let's do the top and bottom. Pi r squared, that's the area of a circle, and I have a bottom and a top. So 2 plus, all right, now I want the side wall. So the side wall depends on the circumference on that circle and that height. So circumference of a circle is 2 pi r. And I got to multiply that by the height, h. Does everyone know where that area formula came from? Oh. Okay. The hardest part is creating a model. That's it. This is what I want to minimize. So that is what I'm going to take a derivative of. Does that make sense to you guys? All right. I want to take a derivative. I do not want to take a derivative with 2 variables. I can, but I don't want to. So what you're going to do, you take your restriction equation. You see this pi r squared h equals 1,000. And I'm going to solve for h. So let's see. My voice got high there. Why did I do that? H equals 1,000 divided by pi r squared. Everyone know where that came from, guys? All right, I'm going to substitute it. So here we go. Area equals 2 pi r squared plus 2 pi r parenthesis 1,000 over pi r squared. I'm going to simplify it. I'm going to do as much as I can without a calculator, and then we'll bring in a calculator. We'll bring it in the big gun when we need to. Pi's cancel out. The r's cancel out. 2 times 1,000 is 2,000. So I'm going to rewrite this as 2 pi r squared plus 2,000 over r. I think I have everything perfect. I'm going to bring that r up so I can take a derivative in a little bit. So 2 pi r squared plus 2,000 r to the negative 1. Since area is what I'm trying to minimize, I'm going to take a derivative. So here we go. A prime equals, the derivative of 2 pi r squared is 4 pi r. And then plus, or I guess minus now, minus 2,000 over, or 2,000 r to the negative 2. I'm going to find my critical number. So this is what I'm going to equal to 0. Are we still okay, guys? All right, so now it turns to a game of algebra. 4 pi r minus 2,000 over r squared equals 0. Arrow. I'm going to move the 2,000 over r squared to the right-hand side. 4 pi r equals 2,000 over r squared. The whole objective is to solve for r. So I'm going to multiply both sides by r squared. So I now have 4 pi r cubed equals 2,000. Hopefully I haven't done any errors. I'm going to divide by 4 pi. and I'm going to take the cube root. So R equals the cube root of 2,000. Oh, you know what? 4 goes into 2,500 times. 500 over pi, and which is approximately, I'm going to use a calculator for this, guys. So I take my calculator and I go 500 divided by pi, and I'm going to raise that sucker to the 1/3. Can I use that word? I can, right? Yeah. I already used it, so too bad. 5.41926. Always put more digits if it allows you to, and that's going to be centimeters. Okay. Something is happening there. Yes, if you graph your derivative graph, it is going to change from positive to negative there. From negative to positive, meaning it is a min. That's what we want. But because we don't have a closed interval, we have to do a second derivative. Because remember before the other two questions, we had a closed interval? Before we had a closed interval, so because we had a closed interval, that's why we knew that was either a max or a min. This time, I can use as much material as I want. So because you don't have a closed interval, guys, I'm going to have to take a second derivative. What do I want?
What is taking a second derivative? Like, how does that give us an interval?
Because the second derivative is going to tell me the concavity of R, of the function.
Why does the concavity of R matter?
Because if I'm concave up, that's a min at that critical point. If I'm concave down, it's a max at that critical point. Does that make sense? So I just want to see my concavity, guys, to see what it is. So I'm gonna take another derivative of A. So there's A prime prime, and check it out. I get 4 pi. Look how beautiful this is, guys. Negative times a negative is a positive. 4,000 over R cubed. Because R is always positive, this expression will always be positive. Let me write that down. Since R is always positive, A prime prime will always be positive. Meaning R equals 5.41926 is an absolute min on the entire graph. Isn't that cool? You guys don't think that's cool? Yeah, I will put centimeters. If there's units, always put units. They wanted my dimensions. I'm not done yet. So, no, we're pretty much done, but not quite. I'm going to save this to A, guys, because I think it's simpler for me. Store alpha A. So look, all I'm going to do, if you want the height, just plug it in here. Height equals 1,000 divided by pi times R squared. So let's see what I get. I'm going to write 1,000 divided by, I'm going to open a parenthesis because the calculator is dumb, pi times A squared. That looks like it's almost twice as big. 8385214. 41, 41, 41, 82. I bet you it is. I don't know. I'm gonna find out right now. Because I have a calculator. I want to see, guys. I don't know. This is the first time I've done this question. Check it out. I want to see if it's going to be a perfect integer. I don't know. I'm going to divide that by A. That's my radius. Oh, wow. Those suckers, man. All right. They surprise me all the time. All right. If the height, so if you have a company and you want to use the least amount, if your height is twice the radius, you will use the least amount of material. The least amount of material. Look at that, guys. We're using mathematics to help us be smarter, to make more profit. Go make more profit. Make your height twice the radius and you will profit. Well, you'll use the least amount of material for a right circular cylinder. Isn't it? You guys don't like this? I think this is beautiful. I think so too. Look at all this math we just did. And this is real math. Like, you know, it's applicable. I can't say that word. You guys will help me out. All right. So the quiz that you're going to take in a little bit.
What?
Thank the online quiz, UH. Thank you, UH, for allowing us the opportunity to take your quizzes. Shout out to you guys. If you guys ever want to sponsor me, swing by. So here we go. These are the type of questions that you're going to have. Find the coordinates of the points in the curve y equals square root of x plus 4 that are closest to the point 7, 0. So before we start, guys, do we know how this graph looks? I hope, say yes. Oh. Square root of x plus 4, here it is, and it just opens like that. Mamas. Can't believe I had to tell Ayala. All right, the point 7, 0 is right there, and I can choose any line. I want the one that is closest to the point. So I don't know, maybe it's that line, maybe it's this line. Obviously, it doesn't look like it's that line. So I'm thinking I have a point, there it is, and that's what they want. They want that coordinate. Do we understand the question? All right, before we continue, I don't want to make sure we understand. I can be anywhere on this curve. I want the point that's going to give me the smallest distance. Does that make sense? Okay. The first year I taught it, when I taught this, I made this really hard because I just went ahead and did, like, it was a crazy chain rule. Because I call this the D. Cool? And I said, we're just doing Pythagorean theorem. We're just doing distance formula. And I did this, guys. I said D equals, don't write this down, just listen. The square root of the change in x. So I'm going to write, this is some coordinate, x, comma, the y value is x plus 4 because it says y equals. So x minus 7, closed squared, plus parenthesis, square root of x plus 4, minus 0, closed squared. When I first taught this, I told my kids to take a derivative of this, and it was crazy chain rule. It's not extreme, it's just more cumbersome. And then I started thinking, like, wait a minute, if I just want to take the shortest, I just want to find the smallest d, I can just change that square root and put a d squared there, and it still works out, but now it's even simpler. I don't have to do crazy chain rule. Does that make sense, guys? This is what I want to minimize. I want to minimize that distance. Who cares if there's a square root or a square?
Why did you use all those random numbers?
Oh, I didn't use random numbers.
How did you put those down? Like, what is it?
Okay, so the whole point is that I want the distance, guys, focus, guys. I want the distance between the curve and the point 7, 0. So any point on this curve is x, that's my x value, comma, this is my y value. Why? Because it says right there. Y is the square root of x plus 4.
So when we find d, we just take the square root of it?
Well, it's just Pythagorean theorem. It's a distance formula.
What?
I did. If you rewind the video, I said it's a distance formula. Okay.
Sorry.
All right. Are we okay, guys? I'm just doing distance formula.
How is that point?
I don't. We're finding it. It can be anywhere. So here we go, guys. All I'm doing, does everyone understand what I'm doing at the moment? Yeah, the distance for. Well, how about I just? Yes, they're all the same. Distance formula. Distance formula. Change in x squared plus change in y squared. Pythagorean theorem. A squared plus b squared equals c squared. They're all the same. Okay, here we go. I'm taking a derivative. I'm taking the derivative of this guy. So the derivative of d, or d squared, I guess, is, if you want to do chain rule here, I guess you can. It's a simple chain rule. 2x minus 7 times 1. And then remember, look, this is being squared. So before I take the derivative, that is just x plus 4. And the derivative of x plus 4 is just 1. Yeah, it becomes so much simpler without the square root in there. And now I'm going to set this sucker equal to 0. Are we still okay, guys? So now look, my second derivative, the derivative of that is 2x minus 14 plus 1 equals 0. 2x minus 13 equals 0. So that means 2x equals 13. Divide by 2, divide by 2. X equals 13 over 2. Why isn't it what? Oh, I'm taking the derivative of d squared. I'm not changing that. You know, it's like saying, if I were to call that y, I would call that y prime. You know what I mean?
Well, then
that makes sense?
square root it?
All right. No, before I solve, I want to make sure. Look, I can pick any coordinate. How do I know that this is a minimum? By taking a second derivative. So look, if I were to take, I'm doing it here in blue, just listen right now so you can observe this, guys. If I were to take a second derivative, I just get the derivative of 2x minus 13 is just 2. That is always positive, always. So if your function is concave up all the time, and I found a critical point, that critical point must be my absolute min. Does that make sense? Okay, write down whatever you have to. Okay, we're good now. All right. At this point, must be absolute min. So I'm going to plug that in to get my y coordinate. This is my x coordinate. So how do I get my y coordinate? Well, the y coordinate is the square root of, what was it again? Was it x plus 4? X plus 4. I'm going to plug that in, guys. Here we go. 13 over 2 plus 4. So I'm going to turn that 4 into 8 over 2. So square root 13 plus 8. 21. That's a 21 over 2. Did they have that? Oh, no, they don't. Here's what they do with that, guys. They want to have a perfect square root in there. Multiply it by 2 over 2, and you get the square root of 42 over 4. What's the square root of 4? So square root of 42 over 2. That's your y coordinate. That's your x coordinate. To get the 4 in the denominator. So the coordinate that will get you the smallest distance or the shortest distance to 7, 0 is square root of 42 over 2. How do we feel, guys? All right, that's it for today's notes. Check out the UH optimization. Today's attempt date anyways. Yes, I will upload a video tonight on this. So let's make an attempt right now, see how we do without the video. And that's it, guys. Yes, ma'am.